In this video, I will be covering writing MapReduce programs in Java using the Hadoop framework. This is different from the streaming programs that you may have done earlier in the course. In this, we will be actually writing a Java MapReduce program that uses the framework and the classes in the framework to define the mappers and reducers. I will highly recommend using an IDE such as Eclipse to assist in the development of the program. What I have here is a project that's already written up in Eclipse. Usually you should just use the new project wizard to define a new Java project. This one's going to be the word count example in Java. Another thing that you may want to do is to add the Hadoop libraries as a reference jar file inside your project. Typically in Eclipse you can do this by simply visiting the build path menu item in the context of the project, and then simply click the configure build path. Over here you'll have a listing of all the jars and class folders that you will be adding to this Java project. Simply click on add external jars and select the jar files that you will need to add for this project. Since we're writing a simple Hadoop program and we're not using any other external libraries, the Hadoop-core jar file will suffice. But if you were to use something in addition to this, for example HBase, you may have to include the HBase jar files. Java experts typically use build systems such as Ant, Ivy, or Maven to simplify the dependency handling process, but those are out of the scope of this video. Alright, once you have the library set up, let's take a look at a simple Java program which performs the word count operation. So I have declared a main class called word count, and I have two subclasses in this class. We have the map and reduce classes, both of which extend the mapper class. This comes from the Apache Hadoop MapReduce mapper class, and we also have one for the reduce class. Apart from these classes, we have a main method, which is going to sort of be the driver method to launch a job and set the map and reduce classes, as well as what the input and output paths are. So let's look at the map class first. As I mentioned, it extends the mapper. In the mapper class in the Apache Hadoop is a generic Java class, so you have to specify the template that we're going to use. And for the mapper class, we are going to specify the input key value types and the output key value types. So the input key value types, in this case, since we're dealing with text, is generally going to be a long writable, which is the byte offset of each line of text in your input files, followed by text, which is the actual value of the string in each line of your text file. Since this is word count, we're just going to transform that into text for each word, and int writable, since we're just going to send one with each line. We're going to send one with each word that appears in the line of text. Once we are in the actual map, we declare a static int writable variable which denotes the int1. We're just going to define this once so that we can reuse it over all mappers. And we also have a text object for each word that we discover on the line. Now in your map function, if you're extending the mapper class in Apache Hadoop, you must override the built-in map function, and this map function has the arguments of the input key value pair as well as the MapReduce context that we are using for our job. So within the map function, we simply get a line variable that is just the string version of the value that is fed into the map. We then tokenize this line, and then for each word in the token, we write to the context the word, which is still in the form of text, and 1, which is in the form of int writable, which is denotes the value 1. So that's the map function, Java version of the MapReduce word count program. Now the reduce version is similar to the map function. We simply declare a reduce class that is going to extend the reducer generic class from the Apache Hadoop library, and we use the template to define that, hey, it's going to have an incoming text int writable key value pair, and it's going to write out a text int writable key value pair. And for the reduce class, we also need to override the reduce function. The parameters for this reduce function are simply the key and value. And notice that the value here is a iterable object of type int writable. So that's what we have as the values that will be passed from the reduce class, and we use the standard context that we are using in the job. We also have some exception handling in here, and all we do is in the reduce function, for each unique key we initialize a sum variable to 0, and we simply sum that up for all the values for that particular key and then write that out into the context. So we've defined the map and reduce classes. Now let's see how a job is defined in MapReduce. We simply have a configuration object. We set the name of the job. We set the name of the jar by the class, which is the name of the main class that we are using here. We also set up the output key and value classes, and we set the mapper class to be the map class that's built into this class. And we also have the reduce class, which is also defined as the class that's the sibling class, the one that is defined within this parent class itself. And we also have the input and output format classes. These are defined to be the text input and text output format classes, which are already defined in Hadoop. And we are also using the file input formats for this job. So we add an input path and we set output paths for the job. Once we've defined everything we need for this job object, we simply call the method wait for completion as true, and then this will in fact execute the job with all of the parameters that we defined. So we have this Java program that's written up in MapReduce. Now in order to ship this to a Hadoop cluster, we need to create a jar file. This is quite easy to do in Eclipse. All you need to do is export your project as a runnable jar file from Eclipse, and it's going to ask you for a launch configuration. You could give it a new launch configuration. Typically a launch configuration will be set up only if you at least run this job once from Eclipse, but it's fine. We'll also give it a name. So let's just go ahead and store this as word count.jar, and in fact we'll call this word count Java, because we already have another word count jar file. Now it'll ask you how you want to handle the libraries. We're going to say that we're going to extract the required libraries into the generated jar. So it's typically what we use to avoid any problems later on. Hit finish, and it's going to compile and write out the jar file. You may receive a few warnings. This might sometimes happen, especially when you add in the jar file to be packaged with the jar, but seems to be okay. Once you have the jar file packaged, you need to actually send it out to your Hadoop cluster that's running Hadoop cluster.